So the next speaker is Samantha Bell, and the title of her talk, Geologic Map of a Segment of the Schrödinger Peak Ring and Potential Rover Traverses.
Can everybody see the right screen?
Yes, we do.
Yeah, great, perfect. Thank you very much. I'm presenting on behalf of a group of exploration science summer interns. Did an internship at the LPI in 2018, where we produced a map of an area of the Schrödinger basin. So as you can see from this diagram, we're looking here at the moon from the South Pole, and the Schrödinger basin's highlighted there in yellow. It's found within the SPA basin, and it's a high priority site for future missions, because a lot of the objectives identified by the National Research Council in 2017 can be accomplished at this location compared to other sites on the moon. So in terms of Schrödinger itself, so it's 320 kilometers diameter and it has this 150 kilometer peak ring structure. So the peak ring, as you can see here, if I just turn this on to laser pointer, peak ring structure is here. And previous mapping in the Schrödinger basin identified different lithologies using M-cube data. So there's mineralogical signatures of anorthositic material, pyroxene-bearing anorthositic material, noritic and troctolitic. So very important lithologies within the lunar crust. So previous mapping has been on quite a detailed level of scale, so looking at individual outcrops and looking at this M-cube data to see what we can find in the peak ring. And models have suggested that the troctolitic material potentially could have been uplifted from 15 to 26 kilometers from within the lunar crust. So it's got the potential to answer lots of important lunar questions from looking at this peak ring material. So this is where our project came in. We decided to take a closer look in detail at like outcrop scale and map a larger portion of this peak ring material, what we deemed as the southwest peak ring, to see if we can identify the geology there and to possibly develop rover traverses. So the data sets that we used included lunar reconnaissance, orbiter images, primarily, but we also combined it with several different data sets, including, as I've already mentioned, the moon mineralogy mapper data. And for the traverses, we obviously had to consider things like slope and elevation as well. So for the geological mapping, we mapped over 15,000 separate shapefile features, and these included, as shown in A, outcrops, and we tried to match these with M-cube data to get an idea of the mineralogical signature of these areas. And we've also got, we mapped craters, 190 fresh craters in the area. In C, we've also got an example here of some of the faults and the grabens that were cross-cutting the peak ring. And in D, we mapped the edge of the talus material, so sort of the boundary of the material that's coming off this peak ring. So this is the geological map that we produced. So we took it a step further, mapped the outcrops, and then we tried to consider such things such as changes in slope to try and put boundaries on different lithologies within this peak ring area. So some of the lithologies to sort of draw your attention to this inferred troctolitic in green. We do have also areas which were what we call investigated unknowns, where we just didn't have enough data to confidently assign that to a particular mineralogy. So in terms of geological interpretations, these are just a few that we wanted to highlight in this talk. So we found that faults, excluding the grabens, were radially orientated with respect to the center of the basin, which could hint that there's more complexities within the way that the peak ring was formed, and possible rotation of fault blocks or interaction with underlying topography that meant that they're not sort of as concentric as you might theorize. And when we were looking at the lithologies, we also considered whether they were in magmatic contact with each other or faulted contacts. So we saw evidence of both, as you can see highlighted in this upper zoomed in portion of label number 5. We've got troxylitic in green in magmatic contact with an orthositic material. There was not a change in slope that would indicate that this was a faulted contact, which obviously can tell us things about processes within the lunar crust and lunar crustal formation. And we also did, on the other hand, have faulted contacts. So this can tell us about how the peak ring formation process and how material comes to be juxtaposed against each other. So overall, without going into all the details, we did find, sorry, I keep jumping. We did find enough reason that this area is particularly geological interesting and would warrant sample return mission, could answer a lot of high priority science goals. So that led us on to planning some different rover traverses in the area. So we had, just to get your eye back in, this is the area that we mapped, shown here in the white square. Zoomed in, we then zoomed in even further into one small area that we targeted. It had to obviously be a combination of somewhere where the rover could land, as much as we'd like to go into this peak material, right up into the peak ring material, it's just not safe, and capture enough of the different geology and the complexity in this area. So we planned a human-assisted robotic sample return traverse mission on a 14-day timeline using an Orion or Gateway element or a modified Heracles architecture. So this is the proposed traverses. We did 3 traverses in the end because there was lots of different sites that we wanted to visit, and working out the best combination inevitably meant that certain things were left out of some traverses compared to others. So this was done sort of as an example of some of the trade-offs that they maybe need to think about in these areas. Traverse A, just to get your eye in, is in white. All have the same landing site and end point. And Traverse A was designed to maximise the diversity of samples, so not as many stations along the way in between some of the key sites. In comparison, Traverse B, shown in purple, was designed to do more in situ analysis at each station, so I had to spend longer at each station and therefore couldn't traverse as far. And samples, Traverse C, sorry, focused in red here on collecting different samples from the different mineralogies identified by this overlay and MQ data here, and the contacts between each of the lithologies. So overall, the scientific potential of any one of these possible traverse routes was quite high. So we could potentially sample from outcrops of material that we've got some signatures of with the MQ data. We can image cross-cutting faults. So just to get your eye in here, this is sort of the edge of one of the grabens.
2 minutes.
Thank you. And we could also potentially collect Schrödinger impact melt exposed from some of these fresh craters like this one on the left. And I'm sorry, these slides keep jumping. And sample lots of different peak ring lithologies, so the anorthositic, noritic, troxylitic mineralogies. And this would serve as ground truthing for MQ data and allow us to potentially investigate that magmatic versus structural contacts that we identified in our mapping work. So this is just the summary. So we created this geological map of this southwest peak ring area of the Schrödinger basin, revealed lots of complex geology that we designed 3 potential 14-day traverses for, and it has the potential in this area to address numerous high priority science goals. For further information on the traverse or the map, please do check out our paper that we've published in Planetary Science Journal for any extra information. Thank you.
Thank you very much, Sam. Excellent talk as well. We have a minute or less for a few questions for you. I'm not seeing anything in the chat box this minute. So I was going to ask you, you propose 3 potential 14-day traverses. Do you have a favorite one, and sort of why, if you had to do only one of the 3?
I think each has sort of had a different favorite one, yeah, the idea would be that it was sort of just to illustrate that you could tailor that particular area to really highlight different things. If you were going to collect all the peak ring morphologies, then Traverse C would be your option. But if it's maybe your first time there, Traverse A could be a good option to get an idea of everything. So yeah, it was a learning curve for us as well, the trade-off between what we would like to do and what we'd maybe be able to do in the time scale.
Okay, great. So with the 0 time mark, Sam, you have another question in the chat box, so you can maybe respond there.